Good afternoon, dear students. Today's class we are going to discuss distinctive behavior of beryllium. When we study the group 1 elements, alkali metals, we learn the distinctive behavior of lithium, which is in the top of that group 1. And here we are going to learn the distinctive behavior of beryllium. It is also in the top of the group 2. It is next to lithium and it is smaller size from this group 2 element. Beryllium is a smaller one. So this is the distinctive behavior, why this beryllium is behaving as distinctive one and why it is behaving as a individual one. We have three characters or three reasons to understand the distinctive behavior of beryllium or the reason for this distinctive behavior of beryllium. First reason is smaller size and high polarizing power. So it has small size and high polarizing power. So this is first reason to behave this beryllium is in a individual way. And the next reason is high electronegativity and the ionization enthalpy is also higher than when we compare with the other elements in group 2 elements. So high ionization enthalpy and electronegativity and higher ionization enthalpy. So we have smaller size and high polarizing power, high electronegativity and high ionization enthalpy. And the third reason here, the same one as like this lithium, we don't have any d orbital in its valence shell. So we don't have any vacant d orbital in the valence shell. Does not contain vacant d orbital. From this distinctive properties or behavior of beryllium, we compare this beryllium with the other element in this family or in this group. So beryllium comparison with the properties of beryllium with the other elements in the group or the alkaline earth metals. Draw a table like this. This is serial number, beryllium, other elements. First comparison with the beryllium. Beryllium can form covalent compound. They can form covalent compound. Covalent compounds. Then this other element can form ionic compounds. Okay, they are ionic compounds. Second character, they have high melting and boiling point. They has high melting and boiling point. In the other element, they have low melting, and boiling point. Third character, beryllium does not react with water even at elevated temperature, though they are not react with water. Okay. They are not reacting with the water. If we apply the heat on that reaction also, reaction 2, they are not reacting. Okay, beryllium is not reacting with water. So even applying the heat or rising the temperature. But other metals which is present in group 2, they can react with water. They are react with water. They can react with water. Okay, so what is the fourth comparison between the beryllium and other element? They not combine with the hydrogen directly. Okay, so beryllium not combine with hydrogen, not combine with hydrogen directly. It not combine. Okay, directly. Okay, note the word is directly. So it is not combining with the hydrogen directly, and the other elements, they can react or they can combine with the hydrogen directly. Okay. Directly. Okay. So what is the next point is, they does not combine directly with the halogen. They are not combined directly with the halogen, but they can combine with some other compound hydrohalides, like they can combine and they can form some halide, beryllium, beryllium chloride or beryllium iodide, beryllium bromide. Likewise, they can form the compound, but that halides are covalent. Okay, they are covalent. So what is the character? They are not combined directly with the halogen. With halogen. Halides are covalent nature. That means in between the halogen and beryllium, they form only covalent bond. So what is the opposite one for the other elements? They can combine directly with the halogen, but the halides which is forming with that halogens are electrovalent compound. Okay, so combine with halogens form electrovalent between this alkaline earth metal and halogens. Next character, hydroxide and oxide of beryllium are amphoteric in nature. So what is amphoteric in nature? They also can react with the acid and also with the basic. Okay, they can react with both acid and base. So hydroxide and oxides, beryllium hydroxide and beryllium oxide are amphoteric in nature. Amphoteric in nature. But these other metals are basic in nature. So we know that they are why we call this alkaline earth metal? Because they are basic in nature or alkaline in nature. So they basic in nature. Oxides and hydroxides are generally basic in nature. Next character, and this is not it is not readily attacked by the acid, because when the beryllium is exposed into the air, they can form a beryllium oxide film on that. So because of that oxide film on that beryllium, they are not readily react with the acid. So not readily react with acid. Acids. So the next one, they are readily attacked by acid or reacting with acid. Acids. So next comparison is beryllium carbide. When beryllium carbide is reacting with water, they release methane gas from that reaction. Okay, so when treating the beryllium carbide with the water, when the reaction between beryllium carbide with water, their resultant methane is a resultant. Okay, so beryllium carbide with water result methane. And in the another side, for the other alkaline earth metals, if the other alkaline earth metals react with water, they produce acetylene. Last comparison of this beryllium and other alkaline earth metals. Beryllium salt are extensively hydrolyzed one. They can extensively hydrolyzing. So they can absorb some amount of water. Okay. So extensively hydrolyzed. They can hydrolyze but not extensively. Okay. So these are the 9 characters or the 9 comparison between beryllium and other alkaline earth metals. Next table or the next one, we have some relation between the diagonal. The beryllium has some relation between aluminium. Why? Because they are in the diagonal relationship. So what is the diagonal relationship? They are placed in the diagonal place of modern periodic table, beryllium with aluminium. Okay. Beryllium is diagonally relationship with aluminium. Okay. Lithium diagonally relationship with magnesium, beryllium diagonally relation with the aluminium. In this case, the size of the ion, radius of beryllium is 0.45 angstrom and radius of aluminium 0.54 angstrom. So they are not a near value, they are not a close value. And the next value for this diagonal relationship is charge per unit area is closer value for beryllium and aluminium. So charge per unit area for beryllium, it is 2.36. For aluminium, it is 2.50. So both are closer value. And also the electronegativity value also it is same. So for beryllium it is 1.5, also aluminium 1.5. Okay, so beryllium and aluminium have the electronegativity value. Electronegativity value is same, and the charge per unit area is also closer, but it is not so close. Okay, so because of these all the characters, they are placed in the diagonal relationship, beryllium and aluminium. So because of this diagonal relationship, they have some similar characters with beryllium and aluminium. Now we're going to see the similarities between the beryllium and aluminium. So similarities between beryllium and aluminium. Beryllium chloride can form the dimer structure. So aluminium chloride also, they can form the dimer structure in the bridge structure. Okay, they can form dimer structure. So which one can form the dimer structure? Barium chloride can form dimer structure. Also like the aluminium chloride. Okay, aluminium chloride. So in the aluminium chloride, they have chlorine bridge. So like the beryllium chloride, beryllium chlorine, chlorine. So another beryllium, chlorine. Okay, like aluminium also have the bridge structure of chlorine. And the barium chloride can form polymeric chain structure. In addition to the dimer, they can form the polymeric chain structure, and both are, that means beryllium chloride and aluminium chloride, both can soluble in the organic solvent and also in the strong Lewis acids. Okay, this is next character. They can soluble in organic solvents and strong Lewis acids. Beryllium hydroxide can dissolve in the excess amount of alkali, and they can give berylate ion. Okay, so beryllium hydroxide dissolved in excess of alkali metals, alkali solution, and they can form the ion like berylate ion. So what is the formula of berylate ion? BOH berylate ion they can form, and hydrogen. When aluminium hydroxide is dissolving in the excess amount of alkali solution, they form aluminate ion. So the same process. So the beryllium hydroxide also dissolving in the excess amount of alkali, they produce berylate ion and hydrogen. So in the aluminium hydroxide also, they dissolve in the excess amount of alkali solution. They form only they also form the aluminate ion. So what is aluminate ion? AlOH4 minus. Okay, this is also one comparison, one similar character with beryllium and aluminium. So beryllium and aluminium ion have the another similarity. They have aluminium and beryllium ion have strong tendency to form the complex. So they can form the complex strong. They can easily form the complex. So like the complexes ion like BeO4 F4 2 minus, Al F6 3 minus, etc. Both beryllium and aluminium hydroxide both are an amphoteric nature. So beryllium with the group 2, other all the elements are basic in nature, but beryllium is a amphoteric in nature. So this amphoteric nature is similar with the aluminium. So beryllium hydroxide and aluminium hydroxide both are amphoteric in nature. Amphoteric in nature. And the next character, during the hydrolysis process of beryllium carbide and aluminium carbide, they can they can produce the methane, undergo the hydrolysis process. That means in the reaction with water they can produce the methane. Okay, so in the beryllium character, the differentiating character with the beryllium and other elements, we already learned this. Beryllium carbide combined with water, they produce methane, and here the same one, beryllium carbide and aluminium carbide both are combined with the water. That means undergo the hydrolysis process, and they produce methane as a resultant one. Okay, so beryllium carbide and aluminium carbide both are undergo the hydrolysis process. They can produce methane as a resultant one. Okay, methane is a resulting process. And the seventh comparison or the similarities between the aluminium and beryllium, both are rendered passive by the nitric acid. Okay, so when reacting with one, they are render the passive character from the both. Okay, next, chemical properties of alkaline earth metals. So the chemical properties of alkaline earth metals. First chemical property, reactivity towards halogens. They can combine with the halogen at an elevated temperature and they form halides. But the beryllium is a different case, you know that. But all the elements, they can easily form the halides. So the formulation of halide metal, that means alkali metal is denoting beryllium, magnesium, calcium, strontium, barium and radium. So here this metal is combined with the halogen. Halogen is fluorine, chlorine, bromine and iodine. So this combining together and they form MX2. So they formed halides. So that for the formation of beryllium halide, beryllium is an exception case. Okay, so the thermal decomposition of NH4 twice BeF4. So thermal decomposition under this one, we can easily prepare beryllium fluoride or beryllium chloride. So this is also the halogen of beryllium. So they can form oxide also. From the oxide we can easily form the halide of beryllium. For example, beryllium oxide undergo the reaction with carbon and with halogen, because it is not readily not directly undergo the reaction with halogen. So we are treating this with the carbon with the halogen. So they form here in the thermal condition. So the condition 600 to 800 Kelvin, under the temperature 600 to 800 Kelvin, it is converted into beryllium chloride, and the excess CO is evolved as carbon monoxide. Okay, so this is the formation of beryllium halide. Next character, reactivity towards halogens. Reaction with the halogen, first one, reaction with hydrogen. This is second character, second chemical property of alkaline earth metals. So all the elements can combine with the hydrogen, but except the beryllium, because we know that general character beryllium cannot combine with the hydrogen directly, but they can so other or the element can combine with the hydrogen and they form the hydrides as a compound of that reaction. So the general formula of this hydride of alkaline earth metals, MH2, metal plus hydrogen, other alkaline earth metals except beryllium. So MH2. This is a general formula. So now going to prepare this beryllium hydride by from that beryllium chloride and lithium aluminium hydride. So beryllium chloride combined with the lithium aluminium hydride. So 2 moles of beryllium chloride combined with lithium aluminium hydride, they form 2 beryllium hydride and lithium chloride with AlCl3. This is the formation of beryllium hydride, because beryllium is not reacting with the hydrogen directly and also it is not reacting with the halogen directly. So that's why in the halogen reaction we treated that beryllium oxide with the carbon and chlorine, they can form beryllium chloride. In the hydrogen reaction they react with the beryllium chloride with the lithium aluminium hydride, they form beryllium hydride. Okay, so this much only today's class. So thank you students.